Hello everyone, in this video tutorial I'll take you through RMST protocol, that is Reliable Multi-Segment Transport Protocol. So that which falls under module 4 of Wireless Sensor Network. RMST protocol is one of the first transport layer protocol developed for wireless sensor network. The main goal of RMST protocol was to provide end-to-end reliability. And this thing is built on top of previous protocol called as Directed Diffusion Protocol, DDP. RMST is designed as a filter that could be attached to the Directed Diffusion Protocol. So this RMST Reliable Multi-Segment Transport Protocol is actually built on Directed Diffusion Protocol, and this RMST also acts like a filter that could be attached to this Directed Diffusion Protocol. RMST provides two functionalities required for transport layer protocol. One is reliable transport, the other one is multiplexing and demultiplexing. So these are the two functionalities that which this RMST actually provides. So here RMST provides two functionalities required for transport layer protocol. One is reliable transport, the other one is multiplexing and demultiplexing. This multiplexing is carried out at source nodes, whereas demultiplexing is carried out at the sink. And RMST provides mechanism to handle errors throughout the routes in the network, and we'll be going through that in a short while. RMST utilizes in-network caching and provides guaranteed delivery of data packets. RMST relies on directed diffusion routing mechanism for a certain path between source and destination. Hence, an implicit assumption is that packets of flow follow the same path unless there is a node failure. So this RMST has two modes of operation. One is non-caching mode, the other one is caching mode. In this non-caching mode of operation, it is very similar to conventional transport layer protocol, where only source and destination play a role in providing reliability. Consequently, the packet losses are detected at the sink and requested from the source node in an end-to-end fashion through an negative acknowledgement packet. The advantage of this mode is that it requires no involvement of the intermediate nodes in a multi-hop network. So here is an example of various nodes with respect to sink, how exactly this communication happens. So let's assume that the sink has received 3 packets, and there is this 4th packet coming all the way from this source to this sink, and in between there is this this packet is getting lost. So message delivery and error. Sink receives an out of order packet and detects packet loss. So it has not got this 4th packet, and all of a sudden it's receiving the 5th packet and there is missing in number. So thereby what sink does is it sends a negative acknowledgement back to the source, negative acknowledgement transmission, followed by this source will again send the actual packet. So this sort of communication is happening all the way between this destination sink and the source node, and there is no involvement of all these routing nodes. So thereby it's called as non-caching, and it's similar to that of conventional transport layer protocol. And whereas the difference in caching mode is that here intermediate nodes on the reinforced path cache the transmitted packets to decrease the overhead in the end-to-end retransmission. So here it so happens that, so here again these black colored nodes are actually here caching nodes. So they have this special capabilities to store the actual packet in them for a short while. So here the source node is transmitting a packet, and let's assume that there is this 3rd packet is getting lost, like we are losing this 3rd packet, and all of a sudden it is transmitting the 4th packet. But here that is message delivery and error. Caching node receives an out of order packet and detects packet loss. So this here, instead of this sync passing the negative acknowledgement here, this caching node itself takes the initiative, that is in its buffer you can see that it has received only the end packet, but there is no third packet. So the previously stored third packet will be available in this node, that which is having this cache capability. So it requests with this node, so it will not pass it on all the way to the source, but instead here in this cache node we can retrieve that packet that which was lost here, and in turn this sends the actual packet here, and later this thing will be passed on to the sink. So here negative acknowledgement transmission to the upstream by the cache node is happening, and followed by retransmission from the cache node itself. So this entire diagram shows error recovery with RMST in caching mode. Then we have this event to sync reliable transport protocol, and we'll be going through that in our next video tutorial. Thanks for watching.